My name is Philippe. I'm working at Red Hat as a software engineer as part of the Podman desktop team. And so this afternoon, we will talk about Podman AI Lab, which is an extension of Podman desktop. So just to know you a little bit before to start, who knows about Podman and is using it for development, okay, right? And who is using Podman desktop also as a UI? Okay, so for the other ones, Podman is an equivalent of Docker. So with it, you can run containers into your machine. So on Linux, you can run them locally with your Linux kernel. And on Mac and Windows, you can run these containers on a VM, exactly like you are doing with Docker. Why Podman AI Lab is an extension of Podman desktop? Because it is using the containers. So what we will see, we will want to run AI applications without having to access to clusters or to other machines. You may want to run it locally into our development machine. And so for this, containers are very useful. And so that's why you are using Podman desktop for all the containers part. So also another question, who has already started creating AI applications? Okay, no, so not so much. So that's good because that's really the target of this talk, to start our first AI application into our machine. And so we can see, like any other project, I think the first step is to do an ideation and to prototype, to make tests. Generally, we do it on Friday when you have some time. Today is Monday, but that's cool. After that, we try to make it more robust. You make a test, you refine it, and so on. And later, you want to productize your application. So AI Lab and this talk is focusing on the first steps about ideation and prototyping. And so the idea of the first application we will try to develop today is to enhance the search into the Podman desktop website. For now, it is using some tool to give you the pages related to some keywords you type into an input. And we will try to use a model that will return the better page for your request. And so for this, we will try to build the search API. We will have a large language model, which is existing, and we will try to create the search API. And by making some, we will try to find the good prompt, and finally to write the search API with Python today. So let's start the demo. So we start with Podman desktop, and we will need, so the demo will be made in a Mac. And so we need a virtual machine. So here I have created already a virtual machine. And you can see it is GPU enabled on Mac. When we are creating a virtual machine, you have two choices, either using Hyper-V or libkrun. And today, libkrun is able to manage the GPU on your machine. And so for now, we need to use this hypervisor to be able to use GPU. So we have the VM, and now we want to install the AI Lab application. So when we go to the catalog, yeah, I don't have any network, but that should be okay. And so I have a Podman desktop. I have AI Lab installed already, so that's okay. And I have one preference, one setting to set as AI Lab, which is to have experimental GPU enabled. And so AI Lab will use the good images for the containers. So when we go to the extension page, you can get some documentation of the extension. And so we can see that it provides a list of models already chosen, which are open source and which can be used as you want. It is able to run inference server to serve your models, so they can be accessed from your application. They with a playground integrated, and so you can try some prompt with your models. And finally, there are some recipes. So there are examples of applications, of AI applications, discussing with models, not only large language models. I mean that there are applications for different than chatbots. We will see it later. And so the first thing we may want to do is to test some playground. So for this, I go to the playground page. I start the playground. I will select the Mistral instruct model, and I create the playground. And so you remember the application I may want to write, and so I will try a few prompts. So I will start with, give me a list of pages in the website Podman desktop.io related to build an image. It is visible. Yeah, okay. And so the model is replying and is giving a list 1, 2, 3, creating a Docker file and so on. So because I want to get the response programmatically, I may want to have the response in JSON format. So I will tell the model to give me the result in JSON instead. So as JSON output as an array of objects with 2 fields, name and URL. So I get the name and URL, and with this I can display this in the Podman Desktop AI website, for example, when I get the result from the search API. So it's a little bit verbose, but in the response, he gives me the response as a JSON. So I think I will be able to use this prompt. And so you have seen that the prompt is every time the user will not type all this prompt every time. So we may want to find a way for the user just to type the build an image part, and for us to have the other part of the prompt sent automatically. So for this, there is a system prompt we can use. And so here into the playground, I will create a new one with a system prompt. This is just a name. And now I will define the system prompt I want. I will replace my specific reply with something generic. So give me a list of pages in the website related to my request, as JSON output, etc. I save the system prompt. And now if I ask start a container, it should still understand that I want a JSON reply. And so it is still giving me the list of pages into JSON format. So I'm pretty happy with this. So now the next step, I want to write my search API with Python. And I'm not sure how to start. And so hopefully there were some recipes. So first, one thing to take care is to stop the services because the inference servers are quite big in memory. So we have to take care to always stop the previous ones. It takes a few seconds. So in the meantime, you can see, so now all the containers are gone, but we will see later that there were containers running when we do this. So the next step is to try a recipe. So here there were different recipes. The first category are for natural language processing. There is a chatbot. There was also a summarizer, code generation, and other related to audio or to computer vision. So the one which is more appropriate for me would be the chatbot. So we will try it. So I have downloaded already the source code, and I can open it. I can look quickly what is inside. So the endpoint, the entry point of a recipe for AI Lab is the AI Lab YAML file. So it describes a list of containers you want to run for the recipe. The first one is the Llama CPP server. So this is the container that will serve the model with the Llama CPP backend. So this is not this part we will look. We are confident it should work, but we will work on the app part, which is the second container. So the second container, the source is in the app directory. So there is a container file, which is the equivalent of a Docker file for Podman. And we can see that the container will run the chatbot UI file with a Streamlit. And so if we are looking at this source code, this is the Python source code. So it is using LangChain. This is a toolkit used to communicate with the model, with the inference server serving the model. And it is using Streamlit to build the website, the page, we will see it. And so if we start the application, I need to get the good model, the same as before. Yeah, volume, I don't have any network. Just 1 second, please. So it should be OK. I need to get the good model, this one. I will start with the recipe. it will pull the images. And so now it is starting the two containers. They are started. And now we can see the details of the application. She's still starting. So now it is green. It should be started. And we can access the application with this button. It will open my browser. OK. And now I still have my prompt here. So if I try this prompt, it is the same model as before, so it should reply practically the same as before. It seems yes. So for now, it is just a chatbot. It is a recipe provided by AI Lab, and it seems to help for what I want. And so what I may want to do now is to get the sources of this application and to adapt it for what I want. So I will stop this one. So again, just one look at the containers. So you can see there are the containers running. They are visible from Podman desktop. The advantage of AI Lab, you remember, running Podman desktop is that you have access to all the Podman desktop UI. And so if there were problems, or if you want to understand how the application is working, you can look at the details of the containers. So here, Podman is also capable of running pods, like into Kubernetes. And so you can see it has created a pod with the containers inside it. So now if we want to continue, we need to stop this one because of memory limits. Where is it? Here. So I delete my application. There is also one service running. I will stop it. And just to check, so I have no containers anymore, so that's OK. And so the next step would be to test my application, to develop my application. So I have started to do something locally. So I have some code. Where is it? Here. The service. I have named it service.py because I want to run a REST service. And so it is still using LangChain, obviously, to communicate with the model. And now it is using Flask because I want to run a REST server. So I didn't change anything practically about the model. It is the same code. The thing I have changed is that I have put the system prompt we have seen before. So reply in JSON format with an array of objects with a list of pages in the website Podman desktop.io, blah, blah, blah. So it should take into consideration this system prompt. And I have created two endpoints for my REST API. The root endpoint, because AI Lab is expecting an health check at the root of the service to be sure that the service is correctly running. And I have created another endpoint. This one is for the application, the query endpoint. And this one will get the query of the user and will send the prompt directly to the model. We'll get the JSON in response, and we'll return the JSON as a response of the query, of the REST query. So we have this. I I can start for now I am working locally, so I will start my Python environment. Yes, one thing before, I need to start a model. So what is interesting with AI Lab is that you can run a service directly, and so it will serve your model with Llama CPP, and you will be able to run your application locally, and it will be able to discuss with the model. I can pick the port I want, 8001. It is a good model. Okay, it is running. We can see here that it is using the GPU inference. And now, if I start the application, so he's checking the model service availability. So he add these URLs, so it is available. And now it has started the REST service at this endpoint. So if I restart my browser, if I go to this endpoint, you remember the OK, which is a health check. And now I can add a query. I can send the application query. For example, how to build an image. And so if it works correctly, we should get a response in JSON format. So during this time, it is asking the model with the system prompt. It is getting the response in JSON format, and it is sending the JSON directly to the browser now. And so you can see this is exactly what I was expecting. And so with this, I have an API server, and my website, Podman Desktop, can use this microservice to get the response. So now I want to share this project with all the team. And so I may want to add this recipe to the catalog of recipe into AI Lab. And so it is not that difficult. So we will see the documentation of AI Lab. There is a contributing part. And in the part providing a custom catalog, so we can get inspiration from the complete catalog file, which is describing all the recipes we have seen before. You remember the chatbot, the summarizer, the code generation, and so on. So we can get inspiration from the chatbot to add our own AI application. And for this, we need to copy a file into this directory. So we will go to this directory. I can stop this. I should have it somewhere. Okay, so into this directory, we can copy a user catalog.json file. I have prepared something. User catalog. I'm not on the right place. Yes, I am. Yes, okay. And so this entry, so it needs a unique ID, search Podman Desktop IO, a description, a name, and what is important is the repository. So it will download the source code. You remember the source code I have looked at the beginning of the chatbot. So here I have placed my own application into this GitHub repository. And so it will be downloaded by AI Lab. Compiler, I would say, it will build the image with this, and it will start the image. And 1 and interesting thing is the recommended model. Here I have put the model I am using for the demo. And so now we have the file into the correct place. If you go to the AI Lab, again, to the recipes catalog, you should see this one appear. So this is the one we just added. It was not here before. And I downloaded it already before the demo, but you should be able to download the sources. And now we may be able to run it directly. We can check the source as the good ones. So they are the same as before. You can see again the system prompt, and you can see the two endpoints. And I have added for this the AI Lab. So I got exactly the same files for the Llama CCP server, and exactly the same thing. I didn't change anything. And I have added a container file just to run my service with Python directly and not with Streamlit anymore. And so now if I start my my application, so it is started. I can go to the details. It is waiting for the checkpoint, for the health check to be ready. So the health check replies OK. And now I can query again something equals build an image and deploy it to Kubernetes. And so it should work just as before. The step before, I was running my macro service locally. Now it is running on a container. The container has been started by AI Lab for you, but it is exactly the same application. And so it replies the same way. And so that's it for the demo. This is what I wanted to show you. So just to finish, I still have 2 minutes to conclude. So what are the next steps we would like to work on for Podman AI Lab? So we may want to add more recipes. For now, recipes are mostly written in Python. I know that they were mostly Java developers here, for example, so we may want to add more Java examples. We may want to integrate with Instruct Lab. So Instruct Lab is a way developed by Red Hat and IBM to train your own model, and adding some RAG, function calling, and so on to the recipes. And so if you want to test it, it is available already. So you may want to have first Podman Desktop, and then Podman AI Lab, which is an extension available directly from the catalog of the Podman Desktop extensions. So that's it. Thanks everyone for listening.